Now we're going to look at section 6.3, the binomial theorem. More likely we're actually using Pascal's triangle. So Pascal's triangle is a famous number pattern named after a French mathematician named Pascal, and you use a tree diagram to generate Pascal's triangle. Now, the nice thing about Pascal's triangle, as we can see it right here, is even if you don't have it handy, it's pretty easy to draw out because there is a pattern. So the pattern is that the value in the first and last node on each row is 1. For every other node, the value in the node is the sum of the two values above it. So if you notice, this 2 here is the sum of 1 plus 1. So our n values will each be 1. This first value here is a 3 because the two nodes above it are 1 and 2. 1 plus 2 is 3. This one is also 3 because we've got 2 plus 1 above it. So this value is 1. This one will be 4, 6, 4, 1. This one's 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. So again, it's pretty easy to make on your own as long as you know how to start it out. Well, what do we actually do with this? We use this to expand the powers of functions. So starting at row 0, so this is row 0, because it's to the 0 power. So anything to the 0 power is just 1, which is the value in row 1. So this is, node 1. This is row 1, so it's to the first power. They're each to the power of 1. This is row 2. So we follow row 2. I'm going to take 1. The first term inside should be squared. The second term would be to the 0 power. The second node in row 2 is 2. We're going to lower the value of our first exponent by 1 and increase the power of our second exponent by 1. And then the last node in row 2 is 1. We decrease a to 0, we increase b to 2. So the exponent of a starts at n, so whatever the row it is, and it's going to decrease. The first term decreases by 1 each term. The exponent of the first term decreases by 1 each term, and the exponent of the second term starts at 0 and increases by 1 each term. So if you add up the exponents each time, they should add up to whatever the power is on the expanded form that you're looking at, n. So the coefficients of the terms in the expanded form are the values in row n of Pascal's triangle. So you look at the power that you're trying to expand, and you'll look in that row to find out what the coefficients are. So it's kind of easier to see it worked out here. We're going to skip that. All right, let's look at this triangle here. So first thing you want to look at is what's the power on your function. So it's a 3, so that means we're going to be looking here in row 3. So we have to think about these are the two separate terms we're going to be working with. So looking in row 3, the first coefficient is 1. Now we take the first term in our binomial, in this case x, should be to the original power, which is 3. The second term is going to be to the power of 0. Now our next coefficient is going to be the next node, so that would be 3. We'll take our first term x, we decrease the power by 1, so it should be x squared, and we increase the power on the second term by 1. We look at the next coefficient, it's 3 again. We take the first term, we decrease the coefficient by 1, we increase the second coefficient, we increase the second term by 1 to get that squared. And then we look at the last coefficient is 1, our first term should now be to the power of 0, our last term should be cubed. So you'll notice with each pair, if you add the exponents, they should add up to 3 each time. That's a good check for you. So simplifying here, x cubed is just going to stay x cubed because that negative 2 to the 0 power is the same thing as 1. Here, when we multiply, we'll have 3 times x squared times negative 2 to the 1. So essentially we're taking 3 times negative 2, which is negative 6, and then we have the x squared. Here we know we're going to have an x to the 1. Looking at the coefficient, we'll have to take negative 2 squared. So negative 2 squared is 4. 4 times 3 is 12. Our last term here, we're not going to have any x's, so we're just going to take that negative 2 cubed, which will get us minus 8. So our terms here would be x cubed minus 6x squared plus 12x minus 8. We got a long one here because we're to the 7th power, so we need to find row 7. That's this one right here. So our first coefficient is 1. We take the first term, x to the 7th, y to 0, plus second coefficient is 7, x to the 6th, y to the 1. Our next coefficient is 21, x to the 5th, y squared, plus 35, x to the 4th, y cubed, plus another 35, x cubed, y to the 4th, back down 21, x squared, y to the 5th, 7, x to the 1, y to the 6th, 1, x to the 0, y to the 7th. So summing up, we get x to the 7th plus 7, x to the 6th, y, plus 21, x to the 5th, y squared, plus 35, x to the 4th, y cubed, plus 35, x cubed, y to the 4th, plus 21, x squared, y to the 5th, plus 7x, y to the 6th, plus y to the 7th.